Assalamualaikum and hi everyone. So we continue page 93 and take a look at this equation. By using shear and moment expression, draw the shear force and bending moment diagram. The question asks you to draw the shear force and bending moment diagram, and then if you look at the question already gave you the direction of cutting. This symbol is the direction for cut the segment. Okay, so you name the segment. This is point A and this is point B. And at B you have a support, which is a fixed support. So fixed support, you have three unknown. You have By, Bx, and also a moment. How do I know the direction? So I assume, okay, by using equilibrium equation, in summation moment is equal to 0, summation Fy is equal to 0, and summation force at x direction is equal to 0, then you will get all the values. So By is equal to 18 kilonewton and MB is equal to 18 kilonewton meter. Okay, so I will not show you the solution. You have to calculate and check the value. Okay, once you calculate the support reactions, then you can start with the equation, how to express the equation. Okay, so as I mentioned, you have this symbol, then you have to follow this direction. So we cut between AB, so with all the By value, which is 18 kilonewton, and also a moment at B is equal to 18 kilonewton meter. Since they gave you the direction, then you have to start from point A. Segment AB, the value of x should be greater than 0 and smaller than 3 meter. Okay, then you draw the free body diagram for the segment. So if I cut here, then this is point A, so you have linear distributed load, and then when you cut here, you have the internal forces, which is V and also M. The distance of cutting, we put it as an X. So the magnitude of this linear distributed load you didn't know. So how to calculate the magnitude of this linear distributed load is you have to do the ratio. The ratio between the small triangle to big triangle. For the small triangle, you have this magnitude, which is we put as W, and the distance is X, and ratio to the big triangle, which is from the equation, the magnitude is 12 with the distance of 3. Then from this you will get your W is equal to 4x. So you put it here, W is equal to 4x. And then same, by using equilibrium equation, you have to come up with the equation. Okay, so we take a look at this segment AB. Start with summation moment at the small x is equal to 0. My definition, clockwise is positive. When I have clockwise is positive, then I have negative 1/2 times 4x times x, and you know that force is equal to, you know that moment is equal to force times distance. So you put a dot. So this is your force. Now what is your distance? So the distance is 1/3 times x. And then what else you have? the internal moment is equal to 0. So you have the moment equation. Now followed by summation Fy is equal to 0, output is positive, then you have negative 1/2 because it is downward, time 4x times x, and then minus Ps is equal to 0. Put the value when x is equal to 0, what is your moment value and what is your v, and then when x is equal to 3, what is your moment and what is your v. Okay, you calculate, and after that, after we get all the values, then we can proceed with the shear force and bending moment diagram. So first you have to draw the free body diagram. So the free body diagram, the maximum magnitude of this linear distributed load is 12 kilonewton per meter, and the support reactions that we already calculated, 18 kilonewton, and the moment 18 kilonewton meter, and the distance from here to here is 3 meter. Okay, then you draw a line. Draw a line and then draw an axis. So now is shear force diagram. You use ruler, okay? So put the label for each axis. Now is a bending moment diagram. Use ruler. The distance here is 0 and here is 3. 0 and 3. Okay, from the calculation, you will get when x is equal to 0, moment is equal to 0. When x is equal to 0, your v is equal to 0. And then when x is equal to 3, your moment is equal to negative 18 kilonewton meter. And when v is equal to 3, then you have your v is equal to 18 kilonewton. And then you plot your graph. So when x is equal to 0, then your v is equal to 0. When x is equal to 3, your v is equal to negative 18. Okay, so if you look at the equation here, you can see this is a quadratic equation. If it is the quadratic equation, then the line should be a curve. Okay, so you sketch a curve. Okay, so you have negative 18, and at here you have 18 output. Negative 18 plus 18 is equal to 0. So you close the loops. Okay, now for BMD is same. So refer back to your value here. Okay, and then you plot. When x is equal to 0, moment is equal to 0. When x is equal to 3, your moment is equal to negative 18 kilonewton meter, and at here you have 18 kilonewton meter clockwise. So clockwise is positive, then 18 is equal to 0. If you refer to this equation also, this is a curved line. It's a quadratic, then it's a curve. So make it curve and then you close the loops. As I mentioned before, if your end point here is equal to 0 and this one is equal to 0, means that your shear force diagram, bending moment diagram, as well as your support relation is correct. And then you put the value, what is your maximum V and what is your maximum moment. So from the graph, maximum V is equal to 18, so ignore the negative sign, and then moment is equal to 18 kilonewton meter. Okay, this is how you solve the linear distributed load. Because the direction of cutting here is given, so that's why I take from A and then I reveal all the internal forces. So what if the direction here is changed? So the question gave you like this. So you have to cut from B. Still same, you have to cut from between AB. But now your shape, if you look at your diagram here, your shape now is a trapezoid. Okay, how to solve the trapezoid? So for this case, so we try this one. If the direction gave you the opposite direction like this, so now you have to cut from B. Still same segment AB, so the x is between 0 and 3 meter, but now you have to cut from B. Now your shape is a trapezoid. At here you have a support reaction which is 18 kilonewton and also 18 kilonewton meter moment. The distance is x, so this is point B. And when you cut here, you have the sign, you have to reveal the internal forces, which is moment and also a shear force, but please refer to the sign convention. Now you have to find the W. So what is the W here? Okay, so we separate this into two trapezoid. So we separate into triangle and rectangular. So to calculate your W, same, small triangle ratio to big triangle. The small triangle W, the magnitude and the distance is x. The big triangle, the magnitude is 12 with the distance of 3. Then you have the W is equal to 4x. So here the magnitude is equal to 4x, and at this point here for UDL, now you have triangle and you have UDL. For UDL is the original magnitude, which is 12 minus 4x. Okay. So this is how you solve the trapezoid. So you do the ratio. When you do the ratio, you will get this magnitude. For the UDL magnitude, you have to minus the original 12 minus the ratio here, then you have the magnitude of UDL. Okay, so let's solve this one. Summation moment at x is equal to 0, clockwise is positive, then you have mx and then plus 12 minus 4x times x, the distance is 1/2 times x. So put the notes. This is your f and this is your distance, and this is for rectangular, the UDL. Okay, and then solve for triangle. Plus 1/2 times 4x times x times 2/3 times x. So again, put the notes. This is your F and this is your D, and this one is for the linear distributed load. Okay, this is 18 times x, the distance, and the moment is equal to 0. This is your equation for moment equation. Now we do for Fy, for V equation. Summation Fy is equal to 0, output is positive, then you have the equation Vx minus, because it downwards, 12 minus 4x times x, and then minus 1/2 times 4x times x, and then plus 18 is equal to 0. Okay, so you should get the same answer. This one you just put the notes. So this is for rectangular, this is for linear distributed load. Okay, so you should get the same answer and you should get the same graph. Okay, because we start with B, then we put when x is equal to 3, what is your M value and what is your V value, and then when x is equal to 0, what is your M value and what is your V value. As I mentioned, you should get the same answer. Okay. Okay, so for page 94, you have to try. This is a linear distributed load also, so you put it as a point C. From A to C is 300, and 300 decline to B. Okay, here is a pin and this is a roller. When you solve this one, you will get the maximum shear is equal to negative. Okay, it should be a negative value, but since I mentioned before you can ignore the negatives, then the maximum will be 375, and then the maximum moment is equal to 450 Newton meter. Since the question did not give you the direction of cutting, so you can choose. Okay, you can start from A or you can start from B, it's up to you, or you can choose both. For example, for segment AC, you want to start from A, it's up to you. Then you have the simple free body diagram. Which is the triangle. Okay. For segment BC or segment CB, so you cut here, cut it here. For segment CB, so you put the X range. Okay, what is your X? If you would like to cut from A, so if you would like to cut from A, then you have the triangle and also the trapezoid. But since I already teach you how to get the ratio, then you can solve this one. Or else, to make your life easier, you can start segment BC, segment CB from CB, no problem, because the question did not give you any direction of cutting. So you can have both triangle. See? Okay, so you can choose. You want to choose this one and this one, okay, no problem. Or you want to choose this one and this one for segment CB. It's up to you. Both are correct since the question did not give you the direction, this symbol. They don't give you this symbol, so you can start from either one, from A, or from A for segment EC and from B for segment CB. No problem at all. Okay, before I move further, I would like to recap a bit on this subchapter, which is you have to develop the shear force diagram and bending moment diagram by using expression or equation method. First, you have to draw free body diagram and then calculate the support reaction. Support reaction by using equilibrium equation. Then when you get the support reactions value, then now you can start cut the segment. Cut the segment by following the direction of cutting by using expression method. By equilibrium equation, then you take out the equations. Moment equation and also shear equation, and then you draw free body diagram with all the support reactions value, shear force diagram and also bending moment diagram in one page. And then from shear force diagram you will identify the maximum shear, and from bending moment diagram you will identify the maximum moment. This method is by using the expression or equation method. For the previous examples that we've done, you already have all the maximum value, which is, for example, like this one, the maximum is at the point that you know. Okay, so what if the maximum moment lies on the point that you don't know? So how to get the maximum moment? You have two methods to get the maximum moment. First, you can differentiate the moment equation, and then is equal to 0, and then you will get the x value, and then after that you substitute back the x in original moment equation, original. Okay, or you can take this v equation is equal to 0, and then you will get the x, and then substitute the x value into the moment equation. So you can choose either one, which one you feel that it is easiest for you. The maximum moment will lies at the point when v is equal to 0, then you will get the maximum moment. How to get the maximum moment? By these two methods. Maximum moment, differentiate the maximum moment then is equal to 0. When you get the x value, then you substitute into the moment equation, the original moment equation, or else you use the v equation is equal to 0, then you get the x value and then substitute into the moment equation. So as I mentioned, moment equation you will get the moment equation when your v is equal to 0. We try this example. So this is a pin, this is a roller, then when you do the support reaction, I just give you the value. You have to find by yourself. AY is equal to 120 kilonewton and BY is equal to 132 kilonewton, while BX is equal to 0. Okay, so here we cut between AB, so I name it as A and point B. This one for segment AB, the distance is x should be greater than 0 and should be smaller than 18 meter. So since the question did not give you the direction of cutting, so you can start either from A or from B, it's up to you, but since I always start from left, then I will start from left. This is the trapezoid. So we already learned how to solve the trapezoid. So at here you have 12 kilonewton per meter, and here is the W, and then at point A you have 120 kilonewton, and then your distance will be x, and then when you cut you will reveal the internal forces, which is V and also M. First we do the W. Okay, so the ratio of smaller with the ratio of the smaller triangle with the big triangle. The big triangle is here. What is the magnitude here? Which is 16 minus 12 is equal to 4 kilonewton per meter. So the magnitude of big triangle is 4, the distance is 18, then your W is equal to 0.222x. So this one is equal to 0.222x. And then again, by using equilibrium equation, take out the equation. Summation moment at x is equal to 0, clockwise is positive, then you have 120 times x minus 12 times x times 1 over 2 times x. So again, put the notes here. This is your force, this is your distance, this is for UDL, and then minus 1 over 2 times 0.222x times x times the distance 1 over 3 times x minus mx is equal to 0. Again, put the notes. So this is your F, the force for linear, and the distance for linear distributed load, and this is the moment. And this one for separation, this is your F and this is your distance. And then for V equation, summation Fy is equal to 0, output is positive, then you have 120 minus, because it downwards, and then minus 1 over 2, 0.222 x times x. So since you already have the notes here, then you can simply take the F value from moment equation here. So that's why the note is important. is equal to 0. Okay, then you calculate when x is equal to 0, what is your moment value and what is your v value. Then when x is equal to 18, what is your moment value and what is your v value. Okay, and then once you finish, you draw the free body, once you finish, we draw the shear force and bending moment diagram. So this is a trapezoid. The magnitude is 12 kilonewton per meter and 16 kilonewton per meter. At point A you have 120 kilonewton, the support reactions, and then at point B you have 132 kilonewton with the distance of 18 meter. Okay, and then draw the line. We want to draw the shear force and bending moment diagram. Shear force diagram. The distance is 0 and 18. And then bending moment diagram. So when you calculate here, when x is equal to 0, moment is equal to 0 and v is equal to 120 kilonewton. And then when x is equal to 18, moment is equal to 0 and v is equal to negative 132 kilonewton. Okay, then you plot. When x is equal to 0, v is equal to 120. When x is equal to 18, v is equal to negative 132. So since this is a trapezoid, then you have a curve. So at point A here you have 120 upwards, so you go up here 120 and then go down until 132. This is just a sketch. Okay, and then you have 132 here, and then you close the loops. And then when x is equal to 0, moment is equal to 0. When x is equal to 18, moment is equal to 0. Okay, since you know when v is equal to 0, when v is equal to 0, then you have a maximum moment. Okay, then you draw here one line, means that this is the line of, means that this is your line for the maximum moment. And then how to calculate the maximum moment? What is the value for the maximum moment? Then you just know the distance is 0 and 18. So what is the distance here until your maximum moment? Okay, you don't know. So as I mentioned, in order for you to calculate the maximum moment, so you have two methods, which is you differentiate the moment equation and then it is equal to 0, or the easiest one, you use the v equation is equal to 0. You can choose either one, but since the v equation is more easier, then I use v equation. From the equation, you have the v equation 120 minus 12 times x minus 1/2 times 0.222x times x minus vx is equal to 0, and then you put the vx is equal to 0. 120 minus 12 x minus you expand this equation 0.111 x squared is equal to 0. By quadratic equation, then you get x is equal to negative 117 and x is equal to 9.21 meter. So which one is the most logic one? Is this one, since we don't have the negative distance. Okay, therefore x is equal to 9.21 meter, and then substitute x is equal to 9.21 meter into a moment equation. So what is your moment equation? So this is your moment equation. Okay, so substitute the x into this equation. So 120 times 9.21 minus 12 times 9.21, 1 over 2, 9.21 minus 1 over 2 times 0.222 times 9.21 times 9.21, 1 over 3, 9.21 is equal to moment. So your moment, the maximum moment, is equal to 567.35 kilonewton meter. Okay, now you have the maximum moment value, and then plot this one. Okay, so we already calculate the maximum moment is equal to 67.35. The distance is 9.21. Okay, so this is a quadratic, then this is a curve. So draw a curve. Okay, so now you have the maximum moment here and also the maximum shear.